back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And today we're going to talk about humankind, the evolution of humanity. If you've been following the news, you know there's been a flood of recent discoveries with regards to the Neanderthals, and even a new species of humans, the Denisovans, which has caught paleontologists off guard. So there's a renaissance as we begin to sequence the genes of our ancestors, and we get to piece together our family tree of where we came from. You know, if you're a fan of the Lord of the Rings trilogy, you know that in Lord of the Rings, humans coexist with other species of humans. There are orcs, there are elves, there are dwarfs, all sorts of different kinds of species of humans. However, many paleontologists have noted that we seem to be the exception. That is, it's just us, Homo sapiens. Where are our closest evolutionary neighbors? Now we're beginning to flesh out our family tree, and it's becoming much more complicated and interesting than we previously thought. And with us today to help to decipher our family tree is a paleontologist. She wrote a book called Close Encounters with Humankind. A paleontologist investigates our evolving species. She's Professor Sang-Hee Lee of the University of California at Riverside. Along with her co-author, Shin-Young Yoon, she wrote the book Close Encounters with Humankind. So in this hour, we'll be talking about the origin of you and me and humanity. So Professor Lee, glad you could be on Science Fantastic.
I'm very excited to be here. Thank you.
Okay, first question for you is, how did you as a youth, when you were a child, what steered you in the direction of science and eventually paleontology?
I'm going to preface my answer by letting you know that my answer is not the one kind of exciting ones that you hear about where you meet somebody or come across an interesting find or go to a museum as a child and kind of get consumed by the passion for the rest of your life. My trajectory was more of, I would say, like an arranged marriage. I picked out my first major as archaeology because archaeology in Korea was one of the first major in alphabetical order. And it turns out that anthropology also is the first major in anthropological alphabetical order. So I was just basically picked a major based on that. And once I started, I found things about that major that really got me interested and feel passionate about the content. When I was in Korea, which is where I grew up, I didn't get a systematic training about scientific approach, and I was more properly introduced and trained as a scientist after I came to the United States to University of Michigan to pursue my graduate degree. So the lesson that I try to share with especially students when they agonize about what major to pick as they think about their life, I always tell them, just pick whatever that it seems interesting even. Don't agonize too much because there are always things and you never know what you're going to find when you start the trajectory or path of a particular pursuit in knowledge.
Okay, but was there some aspect of paleontology that fascinated you about the evolution of human beings? Because it tells a story about where we came from. What are your thoughts?
Yes, that's definitely where we came from, but more about why we are the way we are right now. So I did not know that there was all these evolutionary explanation or hypotheses that could be projected or generated as an hypothesis that can be tested using actual data. And for me, the teasing apart of hypotheses that are empirically sound versus, oh, interesting, but it's really just a story that could never be proven or disproven, was that process itself was the most fascinating fascinating part for me. And then to look at us right now and to see how we look, how we behave, and how we look at our world, and to see that some of it, at least, if not all of it, has some relevance to our evolutionary path. That was the most fascinating part.
Okay, well, let's start at the beginning, because one of the big questions in all of paleontology is, what separated us from the apes? Now, DNA evidence and fossil evidence seem to indicate that about 3 to 4 million years ago, we were very close to the chimpanzee, our evolutionary neighbor, but something split us off. Something split us off from the other apes 3 to 4 million years ago, looking at the DNA evidence, looking at the fossil evidence. And the question is, what was it? Was it tools? Was it walking upright? Was it the big brain? What was it that steered us in this totally different direction from the rest of the apes?
That's an awesome question. And all those three, plus the tool use, was what Charles Darwin thought that separated humans from all the rest of the animal kingdom. And so the natural expectation is, when we kind of gotten used to the idea that there is some evolutionary progress or evolutionary trajectory, that there were some ancestral beings that looked different from how we look and how we are right now. And once we had the idea that there were ancestors for humans, then the question of what did those ancestors look like and what can we expect to find in them, that was where the idea of package of big brain, upright walking, which is bipedalism, tool use, and reduced teeth came to be promoted.
Welcome back to Science Fantastic with Professor Michio Kaku. If you've been following the internet about this explosion of discoveries concerning the Neanderthals and concerning our own human evolution, then maybe you want to get a copy of this book. It's called Close Encounters with Humankind. A paleontologist investigates our evolving species. Now, there's one theory that a paleontologist proposed on this radio station, in fact, and that was that in Africa, the climate began to change, and the forests began to recede, and grasslands and savannas began to come in, and forest creatures like our ancestors, which look very much like a chimpanzee, could not survive very well, so they had to run and survive in the savannas, and for that they had to walk upright. They had to see above the grasslands coming into Africa. Now, how has that theory held? The theory that upright posture evolved first because we had to look over the grasslands of Africa because the climate was changing. What are your thoughts? Is that theory held up?
Not really, in a sense that the reason of what bipedalism allows us to do is not necessarily why it came about. It's like cell phones, the origin of cell phones would be to make phone calls, but what is good right now is to surf the internet in its current form of smartphones. So why bipedalism came about is not necessarily linked to what it allows us to do in terms of its functionality. But this brings back to our previous segment about what makes us humans different from animals. As you pointed out just now, Professor Kaku, that bipedalism came first and earlier than any other things that make us humans. Like big brain comes later, tool use comes later, reduced teeth comes later. It's the bipedalism that comes first. And the previous century, 20th century thought was that it's because it allowed us ancestral humans, to survive better in savanna. And that was about 2 decades of heated discussion about whether the first hominins, the ancestral humans, were fully bipedal. That idea became the mainstream thought until the early 21st century, the publication of Ardipithecus ramidus, which shows that if Ardipithecus ramidus were indeed the first ancestral hominins earlier than the first, Australopithecus afarensis, the Ardipithecus ramidus shows adaptation for tree climbing. Their big toes are divergent. It kind of looks like our hands. Now, human feet, the bipedal feet, look nothing like our hands, right? The big toe is aligned with the rest of the smaller toes, whereas our thumbs are diverging off from the rest of our fingers. And the Ardipithecus, about 4.4 million years ago, had a toe that was divergent like apes. So that's the end. Not only that, also isotope data show that they were adapted to woodlands, not savanna. So our very first hominin ancestors basically being successfully adapted to savanna environment, aided by bipedalism. That idea is getting to be challenged or re-examined at least about whether it was actually the tree climbing arboreal adaptation or combination of a tree climbing and bipedalism that characterized our very first ancestors. Either that or Ardipithecus is not our ancestors. That would open up a whole new possibility of new scenarios.
Okay, well, some paleontologists believe that if you look at the human body, you can see remnants of what our ancestors might have looked like. For example, the opposable thumb. The opposable thumb, they say, probably originated because we swung in trees. And your grasp is about the size of a tree branch, and only later did it evolve into the modern thumb. And tails, that we have a tailbone, meaning that at some point in the past, perhaps we had a tail. And also our back has a sway back. We think the sway back of our back looks very nice, but probably it was because we used to swing in trees and walk on our knuckles. And then when we walked upright, that wrenched our back backwards. So has that held up? The idea that our human body has remnants of the body of our ancestors.
Definitely. That whole idea of our body writing our evolutionary history, that idea is still valid, but the specifics, of course, have changed with new data. For example, opposable thumb is not unique to humans. It's basically all primates can do the opposable thumb, and that is why they are arboreal animals. Primates are generally and originally adapted to treetop living. What separates our thumb from the others is that we could make the OK sign, or we call it the precision grip. The thumb can meet the index finger, and that gives us the kind of precision and coordination to make tools ultimately. And so that will be the mixture of our ancestral state, which is the opposable thumb, plus the precision grip that is only uniquely human. So people say that non-human primates, like apes, they are as strong or actually stronger than humans, but they do not make as ordinate a tool as humans can because they lack the ability to pinpoint and make the precision grip. Also, the sway of the backbone, the vertebral column, is definitely an adaptation to upright posture, to have the efficient transmission of the central mass from the top to the ground. But whether our ancestors were knuckle walkers like the apes is not well supported. In fact, we think that the knuckle walking is also a specialized adaptation for the other apes, which chimpanzees and gorillas.
Okay.
Tail.
Now
Yeah,
go on.
ahead. Oh,
I know. What about the tail? Why do we have
The
tailbones?
Yes, that's because, of course, all of us used to have tails, but it's not only the humans who do not have tails. It's humans and the most closely related lineage to the humans, who are the chimpanzees and gorillas and orangutans and gibbons, of course, as well. The apes, they all lack tails. So taillessness, the trait of having no tail, is one that is common to humans and apes.
But originally, does that mean that our ancestors far into the past had tails?
Yes, it does. Yes, it does. Because the rest of the primates have tails. Monkeys.
Okay. Now, the big question. The big question is, why the big brain? Some people think that the big brain evolved very late in our evolution. Some people think it happened before. But why did we have such a big brain?
That's a very good question, and it kind of goes back to our earlier conversation about bipedalism. Why do we have big brains is not necessarily what our big brains good for. And we have more confidence answering the second question, what are big brains good for, than the first question, why is it there in the first place? So let me share with you some thoughts about the big brain. One is, of course, the information storage and processing capacity. So the big brains will allow us to have a lot of information to be stored and to be accessed and processed. The question, of course, interesting question.
Okay, Professor Lee, we have to take another short commercial break, but afterwards we're going to talk about big brains and the Neanderthals, because there's been an explosion of experimental and also DNA evidence concerning our ancestors and species of humans. Fantastic with Professor Michio Kaku. Today we're talking about close encounters with humankind. We have a paleontologist right with us, Professor Sang-Hee Lee of the University of California at Riverside, and we're talking about the origin of humanity. Where did humans come from? And we last left off talking about the big brain. Some anthropologists believe that we evolved the big brain because we humans are, well, we're rather clumsy. We don't run very fast. We can't smell very well. We can't fly. We don't have big claws. And because we're a rather silly-looking animal, we have to compensate. Compensate for the fact that we can't fly, can't run very fast, and that's the big brain. But what are your thoughts? What are the latest theories now concerning why we evolved a big brain compared to the animals?
Traditionally, the predominant thought about why we have big brain has to do with knowledge and information. And what kind of knowledge and information? It's about civilization, tools and culture and all these great technology and skill to make those technology and innovation. That was the sort of predominant thought. What the second very interesting thought came up, especially with Robin Dunbar, is what we call the social brain hypothesis, where the reason for those big brains is not necessarily for technology and civilization and culture. It's about society, community. As we grow the size of our community, the information that needs to be stored and accessed is about the information about those members of the social group that we belong to, and all the basically gossip nature about each other. And when you look at the correlation between the social group size and the brain size over all the animal kingdom, there is a strong correlation between the animals with larger group sizes having larger brains. So we would take that from inference and apply that to human evolution and say, okay, so when we have these big brains, we probably can hypothesize that when we started to rely much on our community.
Okay, now some people ask a simple question, why didn't the dinosaurs get a big brain, given the fact that they were on the Earth for 200 million years? We've only been on for maybe 100,000 years. And the dinosaurs had many varieties, many social different kinds of orders and things, but none of them evolved a big brain to the best of our knowledge, right? So maybe a big brain is over-exaggerated. Maybe Mother Nature really doesn't need a big brain, but what are your thoughts?
True, and that brings us to our earlier discussion about the reason something came about is not necessarily the reason why something is there. So why do we start to have a big brain? That hypothesis is probably very difficult to directly test. So, in other words, for all we know, we start to have big brains just because. And one of the interesting hypotheses that is out there is the radiator hypothesis, saying that the big brain is there to dissipate our body heat as we adapt to the hot weather climate.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Professor Sang-Hee Lee of the University of California at Riverside, author of a new book, Close Encounters with Humankind. A paleontologist investigates our evolving species. Well, first of all, let's talk about the Neanderthals. Where do they fit in our family tree? How much DNA do we have from the Neanderthals? And if you subscribe to something called Ancestry.com or 23andMe, they actually analyze your genome and give you a number about what percent of your genome comes from the Neanderthals. So let's ask the question, where do the Neanderthals fit in our family tree?
Right next to us. We now know that the Neanderthals and humans, ancestral humans, interchange their genes, they're interbred and had offspring. So if we apply the classical concept of species, where different species mean you cannot interbreed and have a fertile offspring, and if you're the same species, that's something that you can do, then definitely Neanderthals belong to the Homo sapiens lineage of one of the ancient populations that came and went.
And another question, why did they went? I mean, what happened to them? Did we replace them? Did we outcompete them? Or were they simply not adapted to the Ice Age? Where did they go, and what is their legacy?
Their legacy is still with us. When the idea that the Neanderthal genes might be in our own genome, there was some wishful thinking that those genes are perhaps not interesting genes or not important to our survivorship. But now we know that actually those genes, some of the genes from Neanderthals, are crucial to our adaptation, to our living right now. And where did they go? I think they didn't go anywhere. They're still here with us. They're past. They're gone in the terms of time because they're no longer here as a group. But then again, none of the groups that we talk about historically are, quote unquote, still here in that sense. I'm sure that there are groups of Neanderthals who got murdered, competed, and have no impact on the rest of humanity. But there are other Neanderthal groups who did integrate and who did interbreed with the other modern humans. So I think that to have this question of what did the Neanderthals do and consider Neanderthals as one group of humans or ancestral humans who acted the same way homogeneously would be a misleading understanding of what actually happened. So some of them are still here. Yeah.
Now, Some anthropologists believe that about 70,000 years ago, there was a cataclysm that affected all of humanity, and only a handful of us, maybe a few hundred, maybe 1,000, survived that cataclysm to then leave Africa and populate the entire earth. So we are all descendants of a small group of Adams and Eves. They gave birth to all of humanity. Some people think it was the eruption of the Toba volcano in Indonesia that wiped out most of humans, leaving only a tiny bunch of humans to repopulate the entire earth. Now, has that theory held up? The idea that Homo sapiens, that is us, we almost faced extinction about 70,000 years ago. What are your thoughts?
We could have. The impact of the Toba eruption is, I think, not fully appreciated by us. Oh, definitely not by. I need to really study up on the impact of the Toba eruption and what impact it had on our history. But the idea that therefore left only a small number of humans who then became the ancestors for all the rest of us, it did not hold up.
Did not hold up or did hold up?
It did not hold up, no. There are more, especially genetic data, show that there was no small bottlenecking that led us to the origin of Homo sapiens.
Okay, Professor Lee, we have to take yet another short commercial break. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is paleontologist Professor Sang-Hee Lee of the University of California, Riverside. And we're talking about Neanderthals, but now let's talk about the Denisovans. We now realize
yes.
There was yet another branch of humanity that we were totally unaware of. Could you elaborate?
Exactly. And by the way, Denisovans are not the only other archaic human group that we are coming to know. There is what we call the mysterious X group as well. And I think more and more data will show that we hugely underestimated the archaic humans who were roaming the earth before us. So Denisovans is a very, very interesting case because it does not have an actual fossil specimen to write home about. It's a piece of finger bone, some teeth, and a piece of toe bone. But the thing is, the whole genome was extracted from those small fragmentary remains, and therefore gave the name to the whole group of humans called the Denisovans. And what I laughed because only last week there was a groundbreaking, shocking perhaps, paper that came out showing that they have now sequenced a genome of a 13-year-old girl who they think is a F1, the first hybrid offspring between a Neanderthal and a Denisovan parent. So what this shows is that interbreeding was going on all over the place, all throughout our history. And that goes against the idea that modern humans, Homo sapiens, has a very clean beginning, origin, and then it is a distinct species from all the rest of the archaic humans who were living in the old world before the quote-unquote modern humans that appeared from Africa.
So maybe Lord of the Rings was not so far off to postulate so many different varieties of humans.
Definitely.
Now, let me ask you a speculative question about the future. Now, some people say that human evolution has stopped because anyone can have children, and there are no more bottlenecks like Australia. So some people think that human evolution has stopped. Other people say, no way, we're still evolving biologically. But what are your thoughts? Do most paleontologists believe that we're still evolving, or have we stopped evolving?
We are still evolving, and if anything, we're evolving more rapidly. We used to think, especially this was a popular thinking in the 60s and 70s, that with the advancement of civilization and technology, that we somehow overcame our biological being and became a purely cultural beings and kind of left our biological past behind. And what we're actually finding out is that we have continued to evolve as we define evolution as the changes in the genetic frequency over time, over generations. And in that sense, the new materials, new generic materials are always appearing, and that is changing depending on the environmental or sexual selection forces. But whatever the causes, the mechanisms of those change, we're definitely changing. And in that sense, yes, we're evolving. Now, are we going to evolve to a different lineage? That's a different question. But also,
okay, well, when I was
yeah.
Yeah?
Yes.
Now, when I was a kid reading science fiction, they talked about future humans having big heads, being bald, and having very tiny, tiny little degenerate bodies. But it seems to me that there's no selection pressure. There's no selection pressure being placed on humans to evolve balding heads, gigantic heads with tiny diminutive bodies. And so that's probably not the way we're going to look in the future. But what are your thoughts?
Well, if anything, I think that our brain is going to get smaller, not bigger. Because if...
Oh, now why is that?
The brain, well, if what our brain is good for is for information storage and process, then definitely we're now relying on hardware, also known as computers, to store those information and to process and access them. So in that sense, our brain is not as important to perform those particular functions. And our brain is a very expensive organ as well. It eats up a lot of our metabolism and our energy. So why would we use so much energy to maintain an expensive organ that does not do or is not as good as doing what its function has been? That would be a big question. And there is actually a hint that our brain size has been decreasing since 10,000 years ago or so, the Neolithic revolution. Whether that decrease is a artifact of statistics, of sampling, or whether it reflects an actual reality, that's something that more research will find out.
Amazing. So you think that one byproduct of the computer revolution is smaller brains. Special guest today has been Professor Sang-Hee Lee of the University of California at Riverside, author of a new book, Close Encounters with Humankind. A paleontologist investigates our evolving species. Once again, this is Dr. Michio Kaku for Science Fantastic. Good day.